Okay, review over logarithms. This is, pretty much all you need to on this. Now, I actually did not put a graph on this, and I'm sticking with not putting one on the test. Okay? Here's how you figure out a logarithm. You're finding out how many sixes it takes to multiply to 16. So, definitely not 1. That's 36. Calculator time. Oh, yeah. How many did it take? It took 3, so 3 is the answer. Okay. How many 5s it take to multiply to 625? 5. That's not going to be 625, I can tell you that. 625. Okay, 4. It took 4, so the answer to that's 4. How many 11s? 2. 2 is the answer. All these have numbers you can figure out this way. Now, figure out how many 3s it could take to multiply to 27, so 3. Okay, it took 3, but it needs to be -3 because it's been reciprocated. Okay, logarithm's an answer to an exponent. Okay, now you're solving equations for x. These all just have one single answer. Okay, if I see x as an exponent, I'm going to put the little thing, I'm going to circle it and split it. How many 8s it take to multiply to 314? There is not a set number. So what you do is use your power, which is x, equal to the log ratio. Log over log. It's called the change of base formula. You got to put the base on the bottom, okay? Okay, so log 314 divided by log 8. These problems on the back, you're never going to be able to figure out unless you use that. It's the only way, brother. Okay. Again, yeah. Okay, next one. Here's a power. Split the power from its base, and then it's 3 times x. That would equal the log ratio with a base of 7 and 18. So after I get that quotient, you're going to divide. So log 18 divided by log 7, and that's going to be 1.49. Then it is time to divide. .5, 50. Okay, now you got doubles, okay? When you have doubles, separate them. It's not going to work, so what we're going to do instead is use these little sunglasses graph here. So I've got 7 and 49. So we want to take the smaller base and multiply that till I can hopefully hit 49. Okay, I did, okay? So what I do is I put 7 to the second power in place of that. So the 7 stays the way it is to the 3x plus 4 power. And the 49 goes to 7 to the second, but then we put a parentheses with the exponent that's already there. We know the 7s can be canceled, and this side I have 3 times x plus 4. And the other one is going to be 4 times x plus 2. Okay, get your x's on one side of the equation. It doesn't matter which one you go with because it's a nice equation with one answer. You don't have to factor. It's like an old school Algebra 1 from like September 1. A lot of people overthink it, okay, and that's 2. So that a lot of people forget what to do on that. Remember sunglasses, and you'll know, okay? All right, I'm very big on the story problems on this, okay? I deposit $300 in a savings account. The account earns 5% interest each year, compounded quarterly. How much money will be in that account after 12 years? So we find the money. But I don't need to set up all those little boxes because I know I'm going to use the compound quarterly equation, okay? So up on the board it is. You have your beginning amount, 300, times 1 plus your percentage of 5%, but it's got to be 0.05, over our frequent quarterly is always 4, and then that 4 also goes out here and it's multiplied by the years. And the new amount of money I don't know because that's what I'm trying to figure out, so that's going to be y. So I take 4 times 12, that's 48. Then in the parentheses we divide by 4 and we add 1. Okay, so 1.0125. All I'm doing is simplifying it as much as I can before I get my answer. Okay, and then when you're solving for y, it's a straight shot on the calculator. 300 times. You don't have to do any fancy things when you just plug it in. 544. You'll go 545 on that. Okay, what the heck? I already did these problems. I'm not going to do them again. I already did that one. What did I do with the... Okay, next one. You deposit $500 in a bank account that earns 3% interest each year, compound quarterly. How long will it be before the account reaches $1,000? So it's asking how long, so then the answer has to be in years. So I've got 500, 3%, 0.03, the frequency's 4, and then 4, oh, I don't know the years, so it's the 4x power, but I should know then what it ends up at. It ends up at 1,000. It's like a piece of a puzzle. Okay, I can't multiply there, obviously, okay? But I can simplify my parentheses. 0.03 divided by 4 plus 1. So 1.0075 to the 4x power, of course, equals 1,000. Now the variable I'm solving for is x, and x happens to be a power. So I put my power, circle that in the base, and split it. Now, I will be using my log ratio. So 4x equals log over log. But first we have to clear this multiplier of 500 out of there. So I divide by 500. I divide by 500, and that's 2. Okay? So 1.0075 to the power of 4x equals 2. So now I know my base goes here, and my equals goes here. And that's how to solve an equation anytime the x is a power. Circle it, split it. There might be something you have to clear, and then after you clear it, it's on to your power equals log over log ratio. Okay, so log 2 divided by log 1.0075. 93, but remember, we have to divide by 4. And this stuff's used all the time, these math skills for like investment things, okay? That's 23.25, so that'll work, 23.25. It'd be 23 years in like 3 months, but, yeah. No, 4 months. No, 3 months, yeah. That's a quarter of a year. Okay, and then the last one. You buy a boat for $4,000. The boat decreases in value by a constant % each year. After 3 years, the boat is worth $3,217. What percent is the boat decreasing by in value each year? So I'm finding the percent. This time I don't have the compound thing to just tell me how to write the equation. We're going to have to generate it ourselves. So dollars in years would be the best units. That's X, that's Y. So dollars per year. I don't know the dollars per year. It's a percent per year, and I don't know the percent, okay? It's going to be P. So curve X comma Y times G to the power of X and Y. Okay, so we start at 4,000. And then what I like to do to get rid of the growth factor is take 100%, but oh, there's nothing else over there, so I need to do 1, and it's decreasing, so minus p, okay? It's like a general thought process. You want to subtract or add to 100, but you don't know. Okay, so we got 4,000 times parentheses 1 minus p to the power of x equals y. Well, I don't know p, so I better be able to replace x and y with what goes in, and I can because 3 would go in for our years, and then $3,217 would go in for the y. Okay, now, we are not solving for a power, okay? We're solving with a parentheses and a power, okay? So, parentheses power, I'm going to replace this with q. I'm going to put an equals down here. I don't need to do a chart because I'm not worried about plus minus on a story problem. So we got 4,000. If it's times, just put q to the third equals 3217. Now we got to clear the q to the third by dividing by 4,000. So q to the third. So 3217 divided by 4,000. 0.80. Then you take the root out of it, gets rid of it. That's going to solve for q. 0.80 to the 1 over 3 power. It's going to be 0.93, okay? So it's 0.93. And now we bring back our 1 minus p. Now, since it's minus, we want to put a 1 in front of the p, so we recognize that that's a negative 1. So I minus 1 minus 1. So I take negative 1p. 0.93 minus 1 is negative 0.07. Divide by negative 1, divide by negative 1, and that's positive 0.07, which is 7%.